So now let's take a look at how we can create a material that simulates realistic fabric and use mental ray and some material network tricks to generate that. But before we do this, let me show you what I would like to achieve. This is one of my renderings I did. And if you pay attention to the fabric with the flower pattern, you will be able to see that, for example, here there's a different stitch pattern than the more grayish one. Also there, the brighter gray has a different reflectivity value than the darker gray. If I go to this image again, you see this specifically here quite well, how the darker blue is less reflective than the brighter blue. And what I did here was not to create just one texture in Photoshop, which then I skin over the complete object. I actually created one alpha image, like this flower pattern. And then this image I use as a blend factor to decide where on the shoe I would like to see a shader with this texture and a shader with this texture. So if I go back to mental ray, let's go to hypershade render perspective layout. Let me click the shoe. You see, for example, that this is a Lambert shader. And before we go in more into the mental ray shader, let me give you a small understanding about what all those different shaders mean. So if you go to Maya and surfaces, you have, for example, anisotropic, Blinn, Lambert, Phong, and Phong-E. And those are the shader algorithms, basically computer graphics started with. Lambert is very useful for very flat or dull surfaces. Phong and Blinn can be used for plastics and chrome. And anisotropic is a material that can be used to simulate brushed metals. But years ago, computers weren't very strong, so the math to calculate or to simulate a surface needed to be very, very simplified, which is why you can generate photorealistic results with those shaders, but it requires a substantial amount of knowledge and practice and tweaking till the results look very good. Now, if you go to mental ray and materials, you see that actually here we have Phong and Lambert, Blinn as well, but we also have car paint, metallic, and the MIA material. So MIA stands for a mental image architecture. And this is, for example, a material that is very, very realistic because the math behind it is more based on how light physics actually works. So they're more computation intensive, but they will quicker produce a result that looks photorealistic in case that is what you want to strive for. Now you might ask yourself why there are so many different redundancies there. Well, the main reason is in case you have a pipeline where you work with the old shaders, then you want to use those shaders because they're still somewhat valid. And in case you use Maya and mental ray and all you want to do is photorealistic rendering, then you could go to the new mental image architecture shaders. So a lot of those are actually basically doing the same what the MIA architecture shader is doing. And you notice that here you have Blinn and Lambert and Phong, but we only have one architecture shader. So let me show you what this one is doing. And I'm going to switch to this outline. Let me select the shoe. Let me delete all this. Let me put in this MIA architecture shader. Let's click on the attributes editor. And Well, let's make those small. So previously with Phong and Blinn, when you needed to create the material, you somewhat basically need to figure out like what shader could work well for what type of surface. Chrome is polished, paper is matte, so for example Lambert would be good for paper or Blinn would be good for chrome. But the mere material basically combines all different surface properties just into one material. So as you see, we have a value called diffuse and we have a value called reflection. Now if I say I would like to make something that is diffuse, I simply turn reflection down and you see it's a matte surface. Now let's say the surface should be somewhat powdery, then I could increase the roughness, and you see by playing with the roughness value how the lighting on that sphere starts to change. Now let's say you would like to make chrome. Well, then I simply increase the reflectivity and turn the diffuse color down, because now I only see the ray traced reflection. Let's say you would like to make sandblasted aluminum, which is maybe kind of bright gray, somewhat reflective, but the reflection itself isn't clear, it's actually very, very blurred. So I could, for example, play with the glossiness, and you can see that with the glossiness the strength as well as the sharpness of the reflection is being affected. So you see that it's a somewhat different approach if you would like to make something transparent. Then we simply play with the transparency. And now this is kind of like a plastic surface without any reflection on it. Now if you would like to have a reflection on it, well then we just increase the reflectivity. And in case it should be transparent plastic, where the surface is reflective but slightly rough, and we can just decrease the glossiness. So again, instead of trying to figure out what material could be good for what object, we simply create one material and then adjust the material properties so it starts to match the type of physical like elements we're looking for. Now that process I'm going to show you is probably somewhat different, and I'm going to make use of a Maya material and a mental ray material. And let me go back to here, and I said that I'm going to use this black and white image to create a blend between two different materials. So let me go back to Maya, and what I need first is from Maya a surface shader, and then the surface shader I'm going to middle mouse button and drag onto the shoe, and then it will be black. Now what's a surface shader? Basically the surface shader is a flat material. As you can see, it just has a color output and a transparency output, and that's it. There's something more this shader can actually do. It does not calculate any 3D illumination, for example reflections or highlights. And we need to use this type of material kind of like as a mule or a container to plug other materials in. Then we can go to utilities, and inside utilities you have something called blend colors. And if I click on this node, you can see that I have color 1 and color 2, and they're mixed together with a blender. Now if I plug this one to here, so middle mouse button, and let's do a rendering, you see that it's kind of like magenta, and that is because red and blue 50% are mixed together. If I set this one to 1 and do rendering, see it's blue, set it to 1, it's red. Now for the blend factor, let's go ahead and bring in this one image with the flower pattern. So I go to my computer, textures, and there is my flower pattern. Click open, and let's do a rendering. And you notice that this one is reddish. Now this is something you have to keep in mind when you use mental ray, and I'm rendering with mental ray. If you want to use a black and white image, kind of like as a stencil map, think about like airbrushing, and you have a stencil map, you put it against the wall, and you use a spray can and spray over. You need to have part of that image to be not only white, but actually really transparent. So I'm going to swap this image out with this image where you see the black is solid, and then what was white I actually made quickly transparent. And let's do a rendering. And then there you see that now, because what is black will be blue and what is transparent will be red. So it's very important to keep that in mind if you use this approach, that you not only need a black and white, like for bump mapping, for transparency, actually you need an image that really has a transparent background. Now I could maybe go ahead and increase the UV repeat for that shoe. Maybe zoom in a little bit so I see the shoe somewhat better. Okay. So currently, color 1 and color 2 are just very flat colors. You see the shoe is pretty bland and boring. Now we can go ahead and actually go to the Mental Ray tab, to Materials, and put in to Mia Materials. And maybe this one I make maybe a blue like this. And let's put it in there. Middle mouse button, of course, and then result to color 2. And this one, middle mouse button, drag to the first color input. And maybe this one I make, so you can see it better, I make it green for the moment. And also this one I make non-reflective, and maybe I make this one reflective and a little bit diffused. And let's render it. And there you can see that actually I have those two materials put onto the shoe using that image as the stencil map. And let me in here rotate the view a little bit. Let's zoom in and let's do a rendering again. And there you can see now that this blue material has a very, very low glossy value, and that low glossiness kind of like creates the, how could I say that those broken highlights on fabric. Something you need to keep in mind: in real life, basically everything is reflective. Paper is reflective, your skin is reflective, metal is reflective, as well as silicone or other materials. The defining factor is how smooth the surface is. Chrome, for example, is super polished. That is the reason why you see a very good and clear reflection. Paper has a very rough surface, which is why you don't really see a clear reflection. But if you put your finger closer to a piece of paper with some light, you might see a very light color bleeding and color reflection on it. Very subtle, of course. And the same is for fabric. Fabric is a little bit reflective. And now you can't really create a material where you have all the small individual stitches, so we have to simplify how we could simulate the effect of fabric inside rendering software. And that is then where, for example, instead of simulating the different stitches, we simply create a reflection which is low and has a very low glossiness to give you that illusion of the material being made out of a lot of, or like thousands and thousands of small stitches. So here, for example, I'm playing a little bit with those settings. So that's basically the first building block, how you could approach the issue or the task of creating fabric materials. Now you see that this, for example, is very diffuse and looks very matte, but actually in Blender, this is also a material that has a very, very low and very blurred reflection. So I could create those shines on it. And then with additional bump mapping, you can break up those highlights even more and then also give the surfaces a little bit of a structure, like what you can see down here. Because now you really get this feeling of that you can see the different like weaving or threading patterns. And to do the bump mapping, we can make use of those black and white images. So let's say we go with the blue one, blue material. Then we could go to bump, standard bump, click on checker box, go to file, and let's rearrange this a little bit. So here I know I have 4x2, so probably maybe 4x4. I have to repeat this a little bit. And then let's say I'm going to use the denim. And then I have, if I click on this bump 2D, 3D, I have bump value. That's of course my texture, and bump depth. Now fabric, of course, is structured. It's not a flat surface, but the bump depth is not really very deep. For example, a wool pullover would be, of course, more three-dimensional, but the material for shoes is rather flat. So I set this maybe to 1. And well, let's do a rendering and see how this one looks. And there we can see now how this, for example, gets a structure. This is rendered with a preview quality. So the result, of course, does not really look very good. Let me set this to production. So it'll take a little bit longer to render. And then the anti-aliasing will help you with the fighting of moires or getting your texture results look better. And there you can see the fabric a little bit. It's way too big, so probably I might have to increase this a little bit more. I'm leaving this currently at 4 because I'm working with a really small window, so I don't have a lot of pixels to work with because I'm doing the screencast. But based on your distance, if I get very close, you might want to increase the numbers, and if I'm more further away from the shoe, you can change those settings. That sounds a little bit awkward, but keep in mind that when you do a rendering, you render an image into a certain set of pixels, and specifically if you have bump mapping, sometimes you can run to the issue of seeing like more array patterns. Anti-aliasing can help, but sometimes if you're too far away, then the fabric texture you might not necessarily see. So changing the UV values for the repeat can then make that bump mapping more visible or fight the issue of seeing a moire effect. So I'm going to maybe set this one down one value more, but for the sake of science, let's try to see what happens with 8. There you see, for example, the creation of those patterns I was talking about. Of course, if I now render this image much bigger, then I have more pixels of an image to generate, and then that effect probably won't necessarily be that noticeable. So let's go back to 4. So it looks like that bump mapping value is still actually way too big, so maybe 0.01. Let's try it again. And actually, of course, that now was too small, so you don't really see anything. So let's remove this one. And at the same time here, I'm going to add a bump mapping as well. So 0.001, I think. No, 0.1. And then here I'm going to use grid pattern. And maybe 0.2. And let's do a test rendering. So there, now you start seeing the different, how could I say that? Different material structures. And again, you see it's all basically based on this idea of having a flat surface, a surface shader, into which we put in a color blender. And then into the color blender, we can put two different materials with their own individual settings. And then with a black and white or black and transparent image, we can define where then that type of material should be visible. And the nice thing is, because this is all texture based with kind of like stencil maps, we could go ahead and maybe play with those values a little bit. Let's say, well, the flower pattern is too big. I don't necessarily want to go back into Photoshop and then create a new material and save everything and reload everything. I simply, inside my 3D software, and that is, for example, what Inside the Lecture was talking about, using 3D as a thinking tool, I could set up everything so that I cut down work time and have the ability to creatively explore different design solutions or variations rather quickly. At this point, I would like to go a little bit more in detail with how you could work with the glossy values of the materials to create that shininess or sheen effect on fabrics. And to do that and to judge our reflections correctly, we need to actually have an environment so that the reflectivity of, for example, the mirror material has actually something inside the scene it could reflect. And what you see here is a very basic backdrop, two small area lights and a big fill area light on top. And if I zoom in a little bit and snap a rendering, we can, for example, if you pay attention to the lower part, see that there's a little bit of interaction of the shoe happening with the background. Now, let me take a snapshot of this image and then just to show you, for example, how much the reflectivity can affect the realism of your material, I'm going to do another rendering. And let's save this one. And there you can see now how, for example, that very blurred reflection, how much that helps to make that material look good. And it also fights dark areas because it reflects, of course, the brighter material below. Also here and along the rim. Another very typical effect for fabrics is the rim highlight, and that can be done by using a Fresnel effect. And the Fresnel effect, if you compare those two images, is how far, for example, the reflectivity of an object or material changes based on if you look tangent or perpendicular onto an object. You see that the edge is highlighted, but the front part is not. And that's what's happening here is basically you have the base reflectivity, and then the further the geometry is tangent to the camera, the more another material will be visible. And the velvet material, for example, is a very typical case for that. Well, most programs also offer you a dedicated velvet material that, as you can see, highlights tangent edges and then makes perpendicular faces a little bit duller. But in case you don't necessarily have it, or you would like to have more control, for example, here you see how nicely and soft those rims are. This one has a little bit more of fabric structure to it, and this one is very broken up. If I go back to Maya, you can see here inside the rendering that the more you get to an edge, or here, the more there's actually a little bit of shininess on it. And then what is facing directly the camera is actually rather flat. And if you take a look here at my shader network, you see that I'm using another material, another sampler, and another blender. So let me delete all this and show you what I did. So this one goes in there, and let's take a snapshot. So that's the material we were working on so far. Now I would like to have another material rendered right just along the tangent parts of my shoe. So I can go ahead, go to Mental Ray Materials, add another Mia material. This one, for example, I make white, make it very glossy, and maybe lower this a little bit, like this. Okay. Now I need another blend node. So I go to Maya and Utilities, Blend. So this one I can put in here. So again, this is result into blend color 1. And then this one I drag into color 2. And then let's delete this. And let's put this one in there. And then let's make a rendering. And there you now see that 50% of this white material or reflective material is actually added all over the shoe, making it look kind of powdery. But what I want is just based on how my camera is rotated, only the edges that are perpendicular to the camera should get this material. And to do this, we can go to Utilities and add a sampler info node. Now what the sampler basically is doing as the name implies, it is sampling the geometry and other whatnots. So I select the second blend, middle mouse button, drag it over the blender, and then here I say facing ratio should be connected to Blender. Now facing ratio is basically calculating what part of my object is perpendicular or tangent, and then it's passing that to the blend. And let's do a rendering. And it is flipped, so not a big deal. Let's delete this and see. So this one goes into the second, which means this one should be in the first. That goes to there. And then this one goes to there. There. Now if I rotate my camera, for example, a little bit, say like this, and I do a rendering, you will see now that those sides are more reflective. And of course the strength is also a little bit too strong, so maybe you can lower this a little bit, and maybe this can go down, maybe this can go a little bit more to there, and then it will require probably a little bit more of fine-tuning to get it to a result so that it looks really nice and kind of like that it really feels like the fine fibers of the fabric are illuminated. And if you're comparing this result maybe with the previous, you can start to see how step by step we're adding more character to that material. Now you might have noticed that maybe from this view, where a lot of the sides of my shoe are actually perpendicular, that then it gets kind of very whitish. Maybe that's a little bit too much. So currently we only use like a brute force with the sampler info, but we can go one step further. So let's say we add a ramp, and the ramp is basically kind of like a ramp. We can blend between two colors. Maybe let's drag this one down on the shoe for a moment, and let's take a rendering. Okay, so that's basically what we're seeing right now. Maybe let's take a look from here. Okay, so we can actually take the sampler, mouse click, drag it to the ramp, go to others, and then say facing ratio should go into our U and V coordinates. And you might have noticed that immediately the sphere preview of that material changed. So now you see that actually I have kind of like a reddish rim, and the rest of the shoe is bluish. And if I now play with those settings, I can adjust how far, for example, I would like one color to blend to the other color. Now let's make this black, and this one we keep black. And then here, this I would like to delete and connect this one back. And then let's see if we can drop the ramp actually into the blend factor. Okay, so that seems to work. Let's rotate to this view. So as before, the sides are pretty reflective. And let's see what happens if we pull the white down. See, with that, I can actually have a little bit more of control over what part of my object should be reflective. You see now, this is the area that is still getting a little bit of this white material. Maybe I put this one to there. Let's do a rendering. You can see now that now this part gets a little bit of sheen. This is pretty dull. This gets a little bit more of sheen. So this material is kind of not necessarily realistic. I'm just trying to imitate how physically such fabric materials would look like. So based on the view, I might have to adjust a little bit those values so I get the result I'm actually looking for. And the last thing I would like to show you now is how we can extend our actually quite respectably growing material tree to turn those monochromatic materials into not only a bumped material, but also add a little bit of color variation to the material or to the color itself. So currently I think those are set to 0. Okay, so I'm going to add another color blender. And I'm going to plug this color blender into the color node for the diffuse. And then here, maybe I select this color and this color. Yeah, they're two different colors. And here with the bump, I'm using again a black and white one, so I have to use a different texture which has a transparent background. So for Blender, I go to File and then select the denim transparent. See, this is black and white, this is black, and then transparent background. And here I have a 4x4 repeat for the UV, so I have to do the same here. That's very important so that your bump mapping, for example, will scale-wise or tile-wise perfectly match the texture I'm creating. Let's do a rendering. We don't really see a lot, so maybe zoom in a little bit and let's do a rendering again. This view, of course. Maybe a little bit too close. Yeah, I was actually inside the shoe. Okay, there. Now there you can see that you can see kind of like a stitch material, because the fabric itself could have different types of threaded colors. Shouldn't be all monochromatic. And now if we add the bump mapping to it, so 0.01, and let's do a rendering. Then you will see that together with the reflections, we get more the feeling of a truly three-dimensional object, because there are kind of like highlights and shadows on it. And probably the bump mapping can maybe be a little bit increased, and the scale of the fabric is also too big, so then one has to scale down. And those are then settings you have to adjust afterwards step by step until you find something you feel comfortable with. And then what we did here, we can also do for the other material so that it's not plain bump mapped, but actually really looks like that it is material that maybe uses different types of threaded colors or uh, two different types of threading that can use maybe a glossy material like polyester or more a diffuse material like wool. And yeah, that is all to how to set up materials for the shader for simulating fabric materials. And then how you can work with the mirror materials and the blend nodes and then the black and white and transparent images to basically quickly have the ability to make adjustments in terms of scale, size, precision, color, etc.